Okay, this is Pearson Edexcel A Level Maths, Stats and Mechanics. We're doing friction on a slope. The information they give us straight away is the slope is at 30 degrees. When you draw a slope, make sure the slope is about right. 30 degrees is a small angle, so draw it as a small angle. Put all the forces on there. They told us the surface is rough, that means there's friction. They've told us acceleration is 1 meters per second squared, so we'll get that on there. A equals 1. We know the motion is in this direction. It's sliding, and they do tell us it's sliding down the slope. If the object is moving, then friction must be at its maximum. So we know that F equals mu R, where R is the normal reaction and mu is the coefficient of friction. So we want to work out what the coefficient of friction is. We can work out what R is, but not yet. So we need to know R before we can work out mu. We've got slope, this direction. The movement is in this direction. So down the slope, we've got forces. F is in that direction. I've got 2g, some part of it is acting down the slope. Don't know how much though. So let's work out how much is acting down the slope. The idea of getting this angle quite small is it helps me be clear about this angle in here. This is 30, so this is 60, so in here is only 30 degrees. 2g acts in two directions. Some of it acts this way, and some of it acts this way. If you draw it approximately correctly, you can see that most of it acts in this direction, and a small part of it acts in this direction. And the part that acts in this direction can be worked out by saying, well, am I looking at the opposite side or the adjacent side? That one there, 30 degrees, that's the adjacent, that's the opposite. So it's the opposite. So in this direction, I have 2g opposite, so sine 30, minus, in this direction, F equals mass, the mass is 2 kilograms, times the acceleration, which is 1. Now I know 2 times 1 is obvious, but you get marks for working, so show you working. 2g sine 30 minus F is 2 times 1. Sine 30 is one you're supposed to know. So sine 30 is a half. If you haven't learned that yet, try and learn it. 2g times sine 30, so that's just g minus. Now F is F max. F max is mu times R. We don't know what mu is. Equals 2. We'll call that equation number 1. So G minus mu R equals 2. We need to know what R is. So R, let's go in this direction now. R goes that way, perpendicular to the slope. But this arrow, by the way, is at an angle. It's not vertically upwards, it's perpendicular to the slope. So R, then we want the part of 2G that acts in this direction. We can see there's the 30 degrees, and it's the adjacent bit to 30 degrees. So R minus 2G, the adjacent bit means it's cos, equals. Now the object is not going through the slope, it's sitting on top of the slope, so the two things are equal, 0. R equals 2G cos 30. Cos 30 is one you're supposed to know, it's root 3 over 2. So that equals G root 3. Equation 2. We've got one equation that requires an R and a mu. Another equation that tells us what R is. So let's get this into there and work out what mu is. So sub into 1 G minus mu times R 2G cos 30. Oh, sorry, I could have done the numbers there, but equals 2. We had already done the numbers there, so I can just put that in. G minus mu g root 3 equals 2. That means that, take that over that side, I think, g minus 2 equals mu root 3g. Take this over this side. Mu equals g minus 2 over root 3 times g. Let's work that out. Hence, mu equals, grab your calculator, let's work out the numbers. Fraction 9.8. Tells you in the exams to use 9.8, so use it. Minus 2 g root 3. Notice I wrote it as 9.8 times root 3, just to avoid the possibility of getting the 9.8 inside the root 3 sign by mistake. 13 root 3 over 49. We've estimated g as being 9.8, so we don't really want that as being the answer. Go S to D, 0.459. Put too many decimal places in this part of the answer, indicate it carries on, and then say hence mu equals 0.46, sorry, to 2 decimal places. That's all they want. So if you're working from Pearson's own book, I'd recommend going to exercise 5C, page 105, question 3+. Otherwise, you might want to try these. So particle sliding down rough slope, mass equals 5 kilograms, the angle's 40 degrees, mu equals 0.3, just work out the acceleration. And in the second one, it's a particle, it's sliding up a slope. Its initial velocity is 5 meters per second. Its mass is 3 kilograms, mu is 0.2. The angle of slope is 10 degrees. How far does it travel before coming to a stop? And then when it comes to a stop, does it stay there? Or does it start sliding back down again? If you want to pause the tape there, I'll come back to those 2 questions in a few minutes. So if you've worked those out, hopefully you began by drawing a picture. You should always do so. So we have a picture. It's a slope. It's 40 degrees, so it's quite close to 45, but I'll still do it as a small angle. It's less than 45 degrees, so I'll do it as a small angle. It's 40 degrees. I know it's sliding down. I know it's rough. I know the F is actually F max, but I'll just put F for now. I've got a normal reaction which goes in this direction. I've got a mass which creates weight in this direction. And the weight created is 5g. It's sliding downwards, so I'll do that. The acceleration is what I don't know, so I'll do the arrow in this direction, but I might get a negative value for the acceleration. Let's do the maths then. Let's begin in this direction. Oh, sorry, the motion is in this direction. That'd be silly to do it in that direction, wouldn't it? Let's do it in this direction. So in this direction, I've got 5g. Now, what part of the 5g is in this direction? Just look at the angle here. This is 40, so this is 50, so that's 40. Notice by doing this quite small, I end up with quite a small angle just here. 40, 50, 40 is the amount in this direction. That's the opposite side to the 40. Opposite is sine. So 5g sine 40 minus the force in that direction, the force going up the slope, just say F for now, equals mass times acceleration. So 5g sine 40 Don't worry, you're not supposed to know what sine 40 is. Minus F is mu R equals M I know, it's 5. A I don't know. You can put in there no, so leave that as equation number 1. Let's do it in this direction now. In this direction, we'll do it with this side actually, save some space. R minus 5G. The part of 5G in this direction, remember that's 50, so that's 40. 40, and it's in this direction, which is adjacent to the 40. So it's 5G cos 40 equals, well, it's not going through the plane, so it equals 0. So R minus 5G cos 40 equals 0. That implies that R equals 5G cos 40. I don't know what that is, so I'll leave it as 5G cos 40 and bring it into this equation over here. That implies that 5G sine 40 minus mu 5G cos 40 equals mass 5 times acceleration. Let's loosen 5 from all this. G sine 40 minus mu G cos 40 equals the acceleration. Mu, I think I know, don't I? 0.3. So G sine 40 minus 0.3 G cos 40 equals the acceleration. Calculator. G is 9.8. 9.8 times sine 40. Make sure you calculate it in degrees. Degrees. Number 1. 9.8 times sine 40 minus wrong number. 0.3 times 9.8 times cos 40. I must have made a mistake there. Worthwhile making it though. Close off cos 40. When I did sine 40 over here, I didn't close the bracket. 40, close it. So 9.8 sine 40, close the bracket, minus 0.3 times 9.8 times cos 40 equals 4.047. So A equals 4.047 ... Too much detail. G was only two significant figures, so we'll expect A also to be 2 significant figures. 4.0 to 2 significant figures. They would let you get away with 4.05 there, but certainly not 4.047 or anything further than that, because you've only got 2 significant figures in your G, so going beyond 3 is certainly unacceptable. Too much accuracy. Well, that's that one. The second one. To begin with, make sure you've done a decent sketch. So as a particle, it's sliding up a slope, so we do a picture. The slope is very small. I can't really draw 10 degrees, it's too small, but as long as it's a small angle, I can clearly see. Going up the slope, initial speed is u equals 5. Put the forces on there. Got its mass, 3 kilogram, produces a weight of 3g. I've got a normal reaction here, 90 degrees to the plane, which I call r. It's moving in this direction. So friction must be in this direction. And I can say actually for this one, the acceleration is certainly in this direction. I'm going upslope. I'm not pushing it upslope. So at the moment I'm going at 5 meters per second, and what I know will happen is I will decelerate. What I don't know is whether when I finish decelerating, am I going to stop, or am I going to turn around and start sliding back down the slope again? And let's start doing the maths. Our direction is upwards, so we'll go upwards in this direction. In this direction, what are all the forces in this direction? None. Got the forces in this direction, minus F, minus 3G. Now how much of the G is in this direction? That's a very small angle in there. It's a very small part of it. There's the opposite, sine of 10. A very small part of it, very small angle, very small sine. Minus F minus 3G sine 10 equals mass times acceleration. Mass is 3. Acceleration, I don't know. Minus F minus 3G sine 10 is 3A. That's negative and that's negative, which means that's going to be negative. That's what we expect. It's slowing down. Then we go in this direction. Perpendicular to the slope, I've got R minus 3G. There's this part here. There's the 10 degrees. It's the adjacent side. Cos 10 equals 0. Equals 0 because it's not going through the slope. It's neither being pushed up by the slope, nor is it going through the slope. So the two things must balance each other out. So we have R equals 3G cos 10. I call this number 1. I call this number 2. I've got in number 1 minus F. Well, minus F, or I suppose F equals F max, which equals mu R. Do I have mu? 0.2, let's put it on the picture. Mu equals 0.2. And equals 0.2 times R, 3G cos 10. Zero 0.2 times 3 is 0.6 G cos 10. Now I can sub into 1. Minus F, so negative 0.6 G cos 10 minus 3G sine 10 equals 3A. Wish I hadn't simplified that 3 out now. In fact, I think we'll just get rid of it. This is 3 times 0.2 in here. So let's just change that to negative 0.2 G cos 10 minus G sine 10 equals A, so that I can go straight to an answer. A equals calculator. Negative 0.2 times 9.8 times cos 10. Remember, always check that you are in degrees. I know I'm in degrees, I've just checked it just now. This time don't forget to close it. Minus 9.8 times sine 10. I don't actually need to close this one because it's at the end of the expression, but put it in anyway. Equals negative 3.63. A equals negative 3.63. It's an acceleration, so it's meters second to the minus 2. Meters per second per second. That's the first bit. Then I found the acceleration. How far does it travel before coming to a stop? Equation of motion. S equals ut plus half at squared, I think. Oh, sorry. doesn't want time, it just wants the distance. Oh, sorry, I'm not looking for time here, so I'm not going to use that equation. I know when it comes to a stop that v equals 0. So v squared equals u squared plus 2as means I find v known, u known, a known, find out s. The final speed is 0. U squared, they gave me the initial speed, it was 5, so 25. I've just worked out a minus 2 times 3.6. Actually, I should have rounded this to 3.6, but never mind. Leave it as 3 for now. S. Rearrange the equation. S equals 25 divided by 2 times 3.63 equals 7.635, and 25 divided by that, 3.44. So it travels 3.44 meters before it comes to a stop. The next bit of the question is, does it then slide back down the slope? When it comes to a stop, we have the forces on the object. The forces down the slope are. Is it worth a new picture? I guess it probably is. We have the same R. We have the same weight. But now, the friction that previously was going down the slope because it was going up the slope is now up the slope. And we'll call this F2. Don't know what that force is. What we need to know, though, is that force sufficient to stop it going down the slope? Which really means, how big can that force be? Well, we worked out in the first part that F max is mu r equals 0.6 g cos 10. And that hasn't changed. F max is still the same. The question is F max sufficient to stop it sliding down the slope? Well, the force trying to make it slide down the slope is the component of 3g down the slope. Let's give this a number, 0.6 g cos 10. Is 5.8. Well, let's put 5.79 is 5.8 to 2 SF. Force down the slope, 3g sine 10, the same as previously, equals 3 times 9.8 times sine 10 equals 5.10 equals 5.1. Okay, the force acting down the slope is 5.1 newtons. The force acting up the slope maximum would be 5.8 newtons. That means the force acting down the slope is less than the potential force up the slope. F max is greater than 5.1 newtons, implies remains at rest. Just to be clear about what that means, what we're saying there is that there is the potential for the friction to reach 5.8 newtons. The total force down the slope is only 5.1 newtons. If 5.1 is less than 5.8, then it's only necessary, and it's only in fact possible, for the friction to achieve 5.1. The friction will equal and be opposite to 5.1. The slope would need to be greater for the object to actually start sliding down the slope. Full marks, I think.